Good evening to all. Today we are going to see about the IR analyzer, that is also called the infrared radiation. The infrared gas is to be present in an air sample means we used to find the infrared rays by using the gas analyzers. Measure the trace gases by determining the absorption of an emitted infrared light source through a certain air sample. The gas detector does not directly interact with the gas. This is the first point. And another one, the gas molecules only interact with the light beam and non-destructive analysis. These are the benefits of the gas analyzers. And the method used for detection. Here we are using two methods to used for detection. First one, the rise in temperature of gas molecules. The another one, the photon detectors. Rise in temperature of gas molecules means the molecules resonate at the frequencies of radiation matching with the natural frequencies. Increase in vibration causes an increase in temperature of the gas. The molecule of resonant frequencies of radiation with respect to the temperature increase. That is the first method. The another one, the photon detectors. Molecules of a specific gas absorb radiation of a specific wavelength. The transmitted spectrum indicates the absorbed wavelength. This is the another method used to measure the infrared rays. Another one, the structure and operation. The structure and operation means here we see that this is the arrangement of in the infrared radiation analyzer. First we give the source, that is infrared. Next another one having one moderator, and next the infrared source is to be split into two ways. One part of wave is given to the sample and another one is given to this reference. The reference cell is having already known value of infrared value, and the sample cell is hold the sample value to be measured. At the end the detector will be placed. Next we go for the infrared light is emitted and passes through the sample gas, the reference gas, with known as the mixture of gases in the sample cells. First, the detector chamber absorbs some of the infrared radiation. It heats up and expands. This causes a rise in pressure within the sealed vessel that can be detected either a pressure transducer or within a similar devices. Here, the infrared source is to be splitted and it's given to the part, half part is given to the sample and another part is given to this different cell. The heat of the infrared radiation is to be increase the pressure of the vessels. That time, the outcome of these two waves is fed into the detector. The detector is used to compare the two rays from these cells, the samples. The combination of output voltages from the detector chambers from the sample gas can be compared to the output voltages from the reference chamber. The output value is to be compared by using this detector. Here we see that this is a arrangement for this is the internal structure of the infrared gas analyzer. We see that here one infrared source is to be given in that place, and this is a motor is used to control the infrared light source, and this is a interference filter. The interference filter is used to filter the light rays and it's to be spitted the infrared rays. And another here see that this is a reference cell and this is a sample cell, and the sample gas inlet and the sample gas outlet. Next we go for the pressure detector. Here the infrared rays is to be given to the reference cell and the sample cell. The gas mixture in that reference and sample cell is to be pressurized by using that infrared radiation. The pressure variation is compared by using this detector. The detector output is displayed by using the display devices. The main use of the detector is used to convert the physical quantity into electrical quantity. We all are know that detector principle, but here the pressure value is to be converted into electrical signal by using this pressure sensor. This is also the sample diagram for this infrared radiation analyzer. This is a sample cell and the reference cell, and the infrared wave is to be split into two ways, and one part is given to this sample cell and another one is given to this reference cell, and to output of these two cell is to be compared by using the detector, and the detector is given the electrical output that is given to these readout devices. Next we go for thermal conductivity detector. The thermal conductivity detector sense the changes in the thermal conductivity of the column effluent with reference to a flow of carrier gas, also known as cathometer, bulk property detectors and chemical specific detectors, non-specific and non-destructive, universal detector and respond to all components. These are the features of thermal conductivity detectors. Next, this is a circuit for the thermal conductivity detectors. This is the same as the Wheatstone bridge. We see that here having the 4 amps of resistance R1, R2, R3 and R4. The third arm is also called as the third arm is the sample, and the R4 is a reference. The TCD, an electrically heated filament in a temperature control cell. During elution of analyte, the thermal conductivity of the column effluent reduces. Filament heats up and changes the resistance. The resistance value in the circuit, the resistance value is to be equal, means the bridges is to be in balanced condition. The any changes in the resistance value, the current flow in that circuit, it give some external current flow, and the goal here we have fixed one meter to indicate the value of this current flow. Next we see that this arrangement is seen that how the resistance value, the resistor value is to be fed into this instrument. Here we see that here this one resistance and this one another one resistance and this another one resistance. This is a sample one, this is a sampling pump, and this is a reference one, and this is the sample and reference resistance. Limitation: less sensitive than other detectors, has a larger dead volume, cannot operate below 150 degrees Celsius temperature set, chemically active components may damage the filament. These are the limitation of this thermal conductivity detector. These are the video link I give for your reference, the H2S analyzer and IR analyzer and thermal conductivity analyzer. If you want to know the activity of these analyzers, you go this videos and you know that proper idea about that. Thank you.